So now we go over to multitask learning. So what is multitask learning? Multitask learning is a machine learning approach for executing multiple, usually related tasks at the same time. And the reasoning behind this is actually how our human brain works, where it mimics human intelligence of performing multiple tasks at the same time. If you take this image of this flower bed, for example, we can easily distinguish at the same time possibly what type of flowers we are looking at, what color the flowers have, or what type of leaves these flowers have, and multiple other things. And this is all done at the same time. So multitask learning mimics this ability of our human brain. And this brings certain advantages. For example, that the performance of your model can improve because you leverage from commonalities across these tasks. You can also improve the generalizability because you learn shared features that are important for different tasks. It also applies some way of regularization because you have multiple loss functions, each one for each of the tasks, that needs to be optimized at the same time. And we actually see examples of multitask learning in the real world. For example, in speech recognition models, where these models are able to recognize both the content of what is being said, as well as identify who is saying it. Or in computer vision, where we're actually able to classify certain pixels within a predefined category, but also locate, okay, where in the image are actually objects. In natural language processing, where you can detect both the sentiment of the text as well as the word type. For example, this is a verb, this is a noun, this is an adjective. And also in autonomous driving, where the car is able to or detect objects such as pedestrians or cars, but also at the same time segment which area in what it is seeing is actually drivable. But we also see already examples of multitask learning in different life sciences domains. And there's one example that I want to dive into a bit more detail in, which is from this paper from Wang et al., where they did cancer outcome prediction. And they presented a network-based multitask learning model for biomarker selection and cancer outcome prediction, where they combined common molecular signatures with cancer-specific signature identification. So this image is taken from their publication. They use gene expression as input information with the labels of the specific cancer type. From these gene expression matrices, they established correlation coefficients. And then they used a network-based multitask learning model to distinguish cancer type specific gene scores, as well as a common gene score for genes being related to cancer in general. And then both of these gene scores, the cancer general one and the cancer subtype specific ones, are used for a classification model to predict these types of cancers. And they compared their methods to more general single task learning approaches, and it actually improved the performance for establishing these different cancer types. And there are also other life sciences domains where we see examples in, for example, in drug effect prediction in drug discovery. This paper from Ramsander et al. In 2015, where they use a multitask learning network for combining the prediction of drug target interactions as well as drug efficacy. But also in plant biology for plant disease prediction, where Keseli et al. In 2022 presented a multitask learning prediction system for predicting both plant species and plant diseases at the same time. This is only the tip of the iceberg. There are many more studies out there. So if you would like to know more on multitask learning, we would like to point you to this good review from Yuzhang and Kyung Yang from 2021 called A Survey on Multitask Learning. And it goes more into details on how multitask learning compares to other machine learning and deep learning paradigms, but also different approaches for implementing these multitask learning models and known benchmark studies that have compared these different approaches. Different optimization strategies for optimizing the loss functions for multitask learning, and even more applications of multitask learning in practice. So then we go back to the hands-on part of this session, where we created an example study on the Kaggle flower dataset. And the goal of this learning is to get hands-on experience with multitask learning using Keras and TensorFlow. We use as a dataset a subset of the Kaggle flower recognition set, and we only took the images of roses and daisies, and we have manually annotated them for flower color. So we took pink, white, and red roses and white and pink daisies. And as a method, we implement both single task learning model architecture as well as a multitask model architecture for classifying both the flower type and the flower color. And we will focus on the flower type classification and compare the performance and see whether the multitask learning architecture would actually improve the flower type classification. So back to the Google Colab. Okay, so in the first part, we import the packages. We use mainly TensorFlow and Keras, as well as scikit-learn. We set some global variables, which are mainly the dimensions of the images, so that all images are in the same size. A random seed, so that we know that every run of this document will give the same output. The number of epochs that the models trained, and the batch size, which is used in training. We download and unzip the directory of flowers. So this directory is structured in a way that the subdirectories are actually the classes of the different flowers as well as the flower color. Then we load all the different images and do some resizing to the dimensions that we've set before. And here you can see an example of how one of these images looks like. So now we're going to get the labels from the directory structures that I mentioned before. We binarize the labels so they can be used by the model, and one-hot encode them. We split the images into train and test sets for the two different tasks. So the training images, the images will stay the same independent of the category, but they get two sets of labels, one for the flower type and one for the flower color. And then here we define and train our single task model. And our single task model is structured as this. So we first have a convolutional layer. We perform some max pooling. We have an additional convolutional layer, do max pooling and flattening, and then we end with a fully connected layer that provides the output. So now it's finished training. So now we define and train our multitask learning model. So here we actually start with these shared layers that are similar to the single task model architecture. But here you also have a fully connected layer that is first shared between the two different tasks, and then each task has its own fully connected layer as well. Okay, so it's almost finished. So we now see that the single task model has an accuracy of 68% for flower type prediction, and we see that the combined model has an accuracy of 90.9% for flower type prediction. We can also plot these over the different epochs, and you see that the multitask validation accuracy is higher for the multitask model compared to the single task model, while the training accuracies are quite similar. So you could say that also the multitask learning model is generalizing a bit better than the single task model.